Hello everyone. Today we are going to talk about process control dynamics and instrumentation. Now this subject is equally important when we are discussing about process principles for manufacturing anything, not just the mechanisms of the process, that is the momentum mechanism or the transport mechanism of mass and heat transfer, but also how these mechanisms are controlled in relation to what kind of product we desire or what kind of operating conditions we want to maintain. Let us take a small example to understand why we need to study this subject. Now, let us assume that we have a reactor. Let's say this is our reactor, and there is some reactant going in, say a mixture of reactant going in A plus B at a given temperature T, and maybe there is some heat source, heat being an operating condition, and what we get in the outlet is C plus D at a temperature TO. Now this TO is probably supposed to be less than 100 degrees. Say this is a condition that needs to be maintained. So we have to make sure that when the products are coming out, this TO doesn't exceed 100. So somebody has to send a message when this temperature starts reaching 100 or above 100, that the process parameters must be regulated. Now what is the main process parameter here? One can be the heat, the other can be the temperature of the mixture that is going inside the reactor. So whatever message will be sent, that should be sent in form of a network. Say there is some network that delivers this message, which will help either this parameter to be regulated or this parameter to be regulated. So this is where our process control comes into play. So this network consists of some instruments or some controllers which will give a signal that the process needs to be kept into a desired level for perfect functioning. So the main reasons why we'll be studying this are: first, we need to maintain the stability of a process. Secondly, we want to maintain safety of a system. Maybe in this example I'll be stating, say if the reaction mixture, the product mixture exceeds a temperature of 100 degrees centigrade, maybe there could be some formation of some complexes which may lead to unstable conditions. So stability parameter comes in, or maybe there could be some blast or anything like that. It could be prone to accidents, so there comes the safety parameter. Then the other possible reasons could be to avoid any fluctuation or disturbance to a process. Avoid fluctuation or disturbance to the process. And the other reason could be to overcome any kind of non-linearity. Say a process which occurs in a very stable manner or in a very uniform manner, that can be monitored easily. So we do not want any non-linearity, like the process should be uniform. So that is why this process control dynamics comes into play. Now, to understand process control, the way in which you can achieve process control and what kind of dynamics should be set to control the process, the first thing that you need to know is modeling of the process. Modeling of the process means having clear idea of what is exactly happening, that what goes in, what comes out. Mainly the two main modeling parameters are the energy balance of the system and the mass balance of the system. So these are the two inevitable parameters that will help us model. Now from this we'll get some equations, and using these equations we will understand how a process can be controlled. Now, most of these process control related problems, they are represented by ordinary differential equations. Ordinary differential equations be in the form of as given here. So this y is our output parameter, and t is with respect to time or some other constraint. Usually it is often related to time in case of unsteady cases, that is where there's maybe some accumulation going on into the system. So this represent the usual process control problems. Now the way of solving this can be either numerical methods or by Laplace transforms. Laplace transforms. So either of these methods can be used, out of which Laplace transforms are most preferred. What happens here is we express as transfer function represented by Gs. Ys is the output and Xs is whatever is fed or input into the system, and Gs is the transfer function, which is the representation of this system. Here the principles of Laplace transform that we usually study in our engineering mathematics is used, and they are carried out to solve the process, be it a first order process that is a process that can be described by a first order differential equation, or a second order process, or a higher order process. So these solution parameters, these transfer functions, give us idea about lots of things like the stability of the process, the way in which this process may be modified, what kind of input can be done to keep the process linear, etc. So this transfer function, that is ys by xs, represented by gs, is a key player in process control, dynamics and instrumentation. We'll be getting to know further about this in the later lectures. Thank you.